Welcome, everyone. Today, we're going to dive deep into a cornerstone of business mathematics. This is a concept that you are absolutely going to encounter time and time again in your careers, whether you're starting your own business, managing the finances for a large corporation, or just trying to evaluate a major investment. We're going to master the loan payment formula, a tool that's all about turning financial theory into real, concrete business decisions. So let's get started.
All right, let's begin not with some abstract formula on a screen, but with a scenario that lands on the desk of business leaders every single day. Imagine this. You found a fantastic opportunity to grow your company. Maybe it's new machinery, maybe it's a bigger office. You've even secured the capital, a $100,000 loan. But here's the real question, the one that truly determines if this whole expansion is even possible. It's not about the $100,000. It's about the monthly hit to your budget. What is the real, tangible impact on your cash flow, month after month? This right here is where mathematics becomes strategy.
You see, that $100,000 isn't just a number you owe. It's a strategic investment. It represents the potential for new equipment that could skyrocket your production. It's a bigger office to house your growing team. It's the capital you need to hire that key person who could change the game for you. So the very first step in turning all that potential into actual profit is translating that business need into a precise mathematical question. What is the true recurring cost of this capital?
Now, to answer that question, we need a specific tool from our financial toolkit. And here it is. This is the formula for calculating the periodic payment, which we call R, for what's known as an ordinary annuity. And I know, at first glance it looks a little intimidating. But our goal today is to take this apart, to really understand its architecture. Because what you'll see is that this formula is actually quite elegant. It's specifically designed to handle the time value of money, making sure every single payment you make covers not just a piece of the original loan, the principal P, but also the interest I that's built up over that period. So let's break it down.
So let's deconstruct this formula piece by piece. Understanding why each part of this equation exists is absolutely critical. It's the key to using it correctly and, frankly, to avoiding some very common and very costly mistakes. This isn't about just memorizing a formula for an exam. It's about deeply understanding the financial principles that are at work here.
First things first, let's get a formal definition for our main concept. What exactly is an annuity? Well, in the world of loans, an annuity is simply a series of equal, fixed payments made at regular intervals over a set period of time. You can think of it as the steady, predictable heartbeat of your loan repayment. Each one of those payments chips away at the principal you borrowed while also paying off the interest that's been charged. It's the engine that drives a big debt all the way down to zero over time.
Okay, so every loan you'll ever encounter is basically built on these three core variables. You've got P, the principal, that's the initial $100,000 you're borrowing. You've got R, the nominal annual interest rate, that's the percentage the bank charges you per year. And you have T, the term, the total time you have to pay it all back, always expressed in years. These are the foundational facts, the numbers given to you by the bank.
Now right here, this is where we need to pause, because we're about to address the single most common mistake I see students and, frankly, plenty of professionals make when they do this calculation. The bank gives you annual figures, right? A 5% annual interest rate. But businesses don't run on annual cycles. They run on monthly cycles. Your budget is monthly, your cash flow is monthly, your payroll is monthly, your payments are monthly. So we have a mismatch. There's a disconnect between the language the bank uses and the language that business actually speaks.
So this becomes the most crucial step in the entire process. We must convert our annual terms into monthly terms to match our payment schedule. That annual rate, R, has to be divided by 12 to find I, our periodic or monthly interest rate. That's the actual interest rate that gets applied to your balance each month. And similarly, the term in years, T, has to be multiplied by 12 to find N, the total number of payments you'll make. I can't stress this enough. Failing to do this conversion is the biggest error you can possibly make. The formula has to speak the same language as your payments, and in business, that language is almost always monthly.
Let's try to frame this in a different way, just to make sure this concept really sinks in. The formula isn't built to look at the whole year in one big chunk. It works on a period-by-period, month-by-month basis. So I is just that little slice of interest you're being charged for 1 month's borrowing. And N is simply the total count of how many of these monthly slices, these monthly payments, you're going to make over the entire life of the loan.
All right, the theory is now locked in. Let's move from the abstract to the practical. we're going to apply this exact logic to our initial business problem and figure out the precise monthly cost of that $100,000 loan. Let's see it in action.
So here's our raw data, straight from our hypothetical loan agreement. Our principal, P, is $100,000. Our nominal annual interest rate, R, is 5%. And remember, for any calculation, we have to express that as a decimal, so 0.05. And the term, T, is 10 years.
Now this slide lays out our roadmap perfectly. Step 1, we identify our variables. We just did that. Step 2, and this is the big one, we convert to monthly terms. We calculate I by taking our annual rate, 0.05, and dividing it by 12. That gives us about 0.004167. Then we calculate N by taking our 10 years and multiplying by 12 months a year, which gives us 120 total payments. And finally, step 3, we just substitute these correct monthly values into our formula and solve for R.
And there we have it. The calculated monthly payment is $1,061.21. Now, for a business manager, this is so much more than just a number from a calculator. This is a new fixed line item in your monthly budget. This is the real, tangible cost of that opportunity for growth. With this number, you can now do a proper break-even analysis. You can forecast your cash flow with certainty. You can actually assess if this whole project is going to be profitable.
So, now that you know how to calculate the payment, let's step up our game. Let's stop thinking like a student just doing a calculation and start thinking like a manager making a strategic decision. What happens if we go back to the bank? What if we try to negotiate different terms? What financial levers can we actually pull to change this outcome?
This right here illustrates the fundamental trade-off, the push and pull that exists in all of corporate finance. Every decision maker has to understand this inside and out. If your main goal is to lower your monthly payment, maybe to protect your cash flow, you really have two main levers. You can try to get a lower interest rate, which is great if you can get it, or you can extend the term of the loan. And this leads us to a really important strategic question. Making your monthly payment lower by extending the loan term. I mean, it seems like an obvious win, right? It gives you more breathing room every single month. But is it really a win for the company in the long run? What's the hidden cost of that short-term relief?
Okay, let's analyze this scenario as if we're the finance manager. You go back to the bank and negotiate to extend the term from 10 to 15 years. Now, look at what happens to your monthly payment. It drops from over $1,061 to about $790. That's a savings of more than $270 a month. That is a significant improvement in your cash flow. However, and this is a very big however, now look at that column on the far right. By stretching out the loan, the total interest you pay over its lifetime skyrockets from about $27,000 to over $42,000. That's an extra $15,000 in cost. As they say, there is no free lunch in finance, and the decision becomes a strategic one. Is that short-term cash flow improvement worth the massive increase in the long-term cost of this capital?
So, after all of that, what's the big idea I want you to walk away with today? How do we move beyond just plugging numbers into a formula and start thinking about sound financial strategy?
These right here are the core principles that take this from a simple math problem to a powerful tool for strategic financial management. The formula gives you clarity on your costs. That conversion from annual to monthly terms ensures you are accurate. Understanding the levers of loan term and interest rate gives you control. And this entire process, well, it forms the bedrock, the absolute foundation of any major investment decision you'll ever make.
And that leads us to our final thought for today, and it might just be the most important one. Look, calculating the payment is a critical technical skill. You have to know how to do it. But it's only half the battle. The ultimate question for you as a future business leader is this. Now that you know the precise cost of your investment, $1,061.21 per month, how do you make sure that the growth you're funding is going to generate a return that not only covers that cost, but smashes it? That right there is the essence of strategic business finance.